Okay, in this video we'll continue with part C of this problem. Traffic engineers will install a signal if there is any 2-hour time interval during which the product of the total number of cars turning left and the total number of oncoming cars traveling straight through the intersection is greater than 200,000. And in every 2-hour time interval, 500 oncoming cars travel straight through the intersection. So we want to find a 2-hour time interval where 500 times the integral of the curve over that 2-hour time interval is going to be greater than 200,000. If we can find such an interval, then they will require a traffic signal there. Alright, so let's see what we can do there. Now, since we only need to find one, in order to justify the installation of the traffic signal, we just need to find one such time interval where where the product of those two numbers is greater than 200,000. So it makes sense that we go to the highest peak on the graph, which is around t equals 14, and go 1 hour to the left and 1 hour to the right. So my lines are a little crooked there, but we want to go between 13 and 15, and we don't want the average number of cars, we want the total number of cars, which is just the integral over that period of time. And so we're going to multiply 500 times the integral of L of t dt, and if that is greater than 200,000, then we need a traffic sign. If it's not, there won't be any other point in the day where that product will be greater than the one we're looking at right there. Well, let's find it first and see. So I'm going to go back to my graph. I'm going to clear draw, and I don't really need this other function here. It's not hurting anything by leaving it in there, but I will turn it off. And now what I want to do is take the integral under that curve, option 7, from 13 to 15, and that gives me 431.99, and I'm going to multiply that times 500, and that gives me 215,965, and that's greater than 200,000, so there is a need for a traffic light. And so that's all we had to do for that problem. 3 simple points there. Alright, that's the end of that particular problem in this video.